Today we're continuing our study of conics. Yesterday you looked at circles. Today we're going to talk about ellipses. First thing we're going to do is start with the standard form of an ellipse. So the standard form is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And let's go down here. Your center of your ellipse, similar to your circle, is h comma k. We have what's called our major and our minor axis. Your major axis, if we take a look at this example, is the longer axis, which would be along your x-axis in this case. Your minor axis is this axis here, which is the shorter of those. That's along, in this case, your y-axis. Now, those obviously can change because we can be elongated this way or we could be elongated the other way. If your a squared is larger, then it's elongated along the x-axis. If your b squared is larger, then it's elongated along your y-axis. To get from your standard form to your general form, we would first of all have to multiply through by the least common denominator. So multiply through by least common denominator and simplify. So in this case, your common denominator would be both an a squared and a b squared. And I'm just going to put it in a different color just to emphasize that. So in other words, I would multiply each one of these by a squared, b squared. Over here, I'd have a squared, b squared. And finally over here, a squared and b squared. So once I multiply all that way through, I end up with ax squared plus by squared plus cx plus dy plus e is equal to 0. And we'll look at a specific example of that in just a few minutes. The last key point on here is what they call the foci. It's 2 points that lie inside the ellipse along the major axis and are c units from the center. And here's one formula that we are going to have to memorize. C squared is equal to a squared minus b squared. And we'll use that down here when we find the foci in just a second. One other thing, let's write down our general definition of an ellipse. And it is any point on the ellipse has a constant distance from the foci. And that constant distance is what ends up creating that ellipse. So let's go take a look at the first example. We have to graph the following. So first of all, if you notice, our h and our k are missing. So in other words, the center of our ellipse in this case is 0, 0. Okay, the square root of these distances tell us our distance up and down and left and right. So this one here, notice it's under the x. When you take the square root of 4, that's equal to 2. That means we're going to go 2 units to the right, 2 units to the left, and those are 2 of my endpoints. If I go take a look at 9, same thing. The square root of 9 is plus or minus 3, so same deal. I'm going to go up 3 units, down 3 units, and then finally I can sketch in my ellipse. So I have my center is at 0, 0. The vertices are these points here. Let's put those down. And notice those vertices in this case are also intercepts. So we end up with 0 plus or minus 2, and we have plus or minus 3, comma, and I have that backwards. This should be a 3, and this one should be a 2. And finally, the other key points we want to find are those foci. And up here, remember, the distance to those foci, we figured out c squared is equal to the absolute value of their difference. So, and it doesn't really matter what the order is. When I take that absolute value, I end up with the same thing. So we have c squared is equal to absolute value of 5. When I go and take the square root of that, I end up with approximately 2.24. And those foci are along the major axis. So I'm going up about 2.24, down about 2.24. And these are my foci. So our foci, in this case I have 0 plus or minus 2.24. Okay, continuing on the back side, again, first thing we want to notice is the center of this ellipse is the point 3, negative 2. So let's go ahead and plot that. We've got 3, negative 2. Again, we're going to take the square root of that 25. We end up with 5. Again, that means I'm going 1, 2, 3, 4, 5 units to the right, 1, 2, 3, 4, 5 units to the left. And then I'm going to take the square root of 16, and we end up with plus or minus 4. So again, from here we're going 1, 2, 3, 4, down 1, 2, 3, and 4. It's just a little bit more elongated along the x-axis than it is the y. And finally, again, we want to find those foci. Again, the distance to that foci is c squared equals the absolute value of 25 minus 16. We end up with c is equal to 3. So that means I have to go 3 units from the center, and I'm going left and right this time because they're along the major axis. So get my green marker. We're going to count 1, 2, and 3. There's one of them. And 1, 2, and 3. There's the other one. And let's go ahead and figure out what those points are. So I'm going all the way out to 5, negative 2. And in this case, I'm going back to negative 2, comma, negative 2. Okay, now this one is where we kind of hinted at the front. This is standard form. I want to go ahead and put it into general form. So remember what that looks like. I have ax squared plus by squared plus cx plus dy plus e. And really, the only key thing here is a, b, c, and d are going to end up being integers. So I'm really just going to expand and multiply everything out. So the first thing I need to do is think about the common denominator between 25 and 16. And I believe it ends up being actually, let's do this. Let's make it a little bit easier. Let's take it back to a 4. And let's go over here, first of all, and refresh our memory on least common denominator. So if I had a 2 and a 3, the least common denominator is 6. If I had a 3 and a 27, the least common denominator is 27. Or 4 and 5, the least common denominator is 20. So 4 and 16, the least common denominator is 16. So I'm multiplying each one of these pieces through by 16. So if you take a look at the first one, I can actually cancel 4 into 16 4 times, and then I have x minus 3 squared. 16 and 16 cancel. I'm left with y plus 2 squared, and then finally 1 times 16 is 16. Now I need to either FOIL this out or box it out, whatever you prefer. I get x squared minus 6x plus 9. If you need to do a little bit more work, then like I said, go off to the side and do that. Next we need to distribute that 4. And then finally we're just going to kind of regroup and also bring 16 over. So I see 4x squared and my y squared. Then I see a 24x and a 4y. Next, I see 36 plus 4, but then when I turn around and subtract that 16, I end up with plus 24 equals 0. So let's go look at the last one. If you notice, this one is actually in that expanded form, and I want to go back and rewrite it in this form so that I can actually graph it. So we're going back to a little bit of Algebra 2. We've got to go and do the process of what we call completing the square. So first thing I'm going to do is kind of regroup my y's and my x's. I'm bumping that negative 184 to the other side. Okay, first thing I need to do is factor out that 25. I'm left with x squared minus 8x. Here's where we go complete the square. I want to make this into a perfect square. So half of 8 is 4 squared is 16. Again, half of 8 squared is 16. Now, what I really did, I added 25 times 16, which means I really added 400 to both sides because I've got to keep that check going with my equation. Next, I'm going to factor out the 9. And again, same thing. Half of 2 is 1. 1 squared is 1. But again, notice I really haven't added 1. I've added 9. So what happens is when I go and factor this, they should end up being 2 of the same factors. That way I can write it as 25 x minus 4 squared. Same thing up here. When this factors down, it should be 2 of the same factors, which it is. Again, that means I can factor it to y plus 1 squared. And then finally on that other side, I end up with 225. And finally, we're almost done. If you think about that form on the front, or even if you look at the example up here, we need to get rid of these coefficients. And I also need to get this to be a 1. So what I'm going to do is divide by that 225 on that right side. Notice I get my 1. 25 does go into 225. It goes in there 5 times, I believe. Let's try again. 9. 9 goes into there 25 times. And now we're ready to graph it. We're going to be working on this some more in class, so if I went a little bit fast, don't worry, we'll focus some more on it because this completing the square is going to come up throughout the entire unit. So now we're ready to graph. I've got my center at 4, negative 1. I'm going to go left 3 and right 3 to my endpoints, and then I'm going up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. And then finally, we're ready to graph. Okay, remember tonight's assignment is on MathSpace.